how are you all? Welcome in this session. Students, we are here to study about the chapter number 7, air and atmosphere. So today we will continue the topic oxygen. You know, oxygen, it is 21% in atmosphere, and oxygen is an essential and supporter of life on earth. These questions you will do with the help of given notes. And here discovery of oxygen, it has been here, this discovery of oxygen. So it was first prepared by Swedish chemist, and name of that chemist is Carl Wilhelm Scheele. So this Wilhelm Scheele in 1772, by heating potassium nitrate and mercuric oxide, they form the oxygen. But he was not able to publish his discovery till 1777, and before that in 1774 Sir Joseph Priestley, he conducted experiment on mercuric oxide with sun rays and liberated a gas, and he noticed that candles burned brighter in presence of that gas, and that is, a mouse was more active and lived longer while breathing it. So Priestley, it is the name of scientist Priestley, was given property of discovery of oxygen, and oxygen is an element was later proved by Anthony Lavoisier. Now occurrence of oxygen, you know that oxygen is present in both free and combined state. The free states in our atmosphere, oxygen is present in free states in about 22% of volume, and it is also present in dissolved state in water bodies, thereby supporting aquatic life. Okay, now its symbol of oxygen is O, molecular formula O2, valency 2, and atomic number is 8. Okay, and atomic weight 16 and molecular weight, that is 32. Now about the oxygen combined state, water is present in plants and animals in the combined state. It is also present in earth's crust, animals and vegetable matter. Now preparation of oxygen, so catalytic, here in laboratory method, the catalytic decomposition, when in presence of catalyst magnesium oxide, this hydrogen peroxide react and it form the water and oxygen. Now from potassium dichromate, also due to the presence of magnesium oxide, it gives the potassium chloride and oxygen, and this figure is given here for the preparation of oxygen gas from the potassium chlorate, KClO3. Now industrial method, from liquid air oxygen can be obtained from the air also, and air is made free from dust particles, carbon dioxide and water vapor by passing through filters or through electric precipitators. Now this air now contains only nitrogen and oxygen. When this air under pressure is allowed to expand suddenly through a small orifice into a region of low pressure, its temperature falls and converts into a liquid. This liquid on fractional distillation, this is important, that after fractional distillation it gives the oxygen. By electrolysis of water, so you know, when electric current is passed through the water, it gives the hydrogen and oxygen molecules. And from metallic nitrates, this one is potassium nitrate, on heating gives the oxygen gas, and sodium nitrate also gives the oxygen gas. Now properties of oxygen, its physical properties. So density here, you know that oxygen gas is heavier than air. It is for this reason that there is more oxygen near to the earth, and the amount of oxygen decreases as we go higher and higher. Now Second property is solubility. तो oxygen is spherically soluble in water and solubility decreases with increasing in temperature. Okay, now effect on litmus. तो oxygen is not change the color in the litmus paper, that's why it is neutral in nature. Now boiling, here boiling and freezing point. Oxygen liquefied at the given temperature and its boiling point is -183 degrees centigrade and freezing point is -218.4 degrees centigrade. Now chemical properties of oxygen here. Oxygen is non-combustible but it supports in combustion, and to prove it, introduce a smoking wooden and splinter in a jar full of oxygen. You will see that the splinter burst into a flame. It's proved that oxygen supports the combustion and help in burning. This oxygen react both with metals and non-metals, and when oxygen reacts with metals and non-metals, it form their respective oxides and it is called the oxidation reaction. Now oxidation of non-metals here. So when oxygen react with sulfur gives the sulfur dioxide, and this sulfur burns with tiny blue flame in the air, and it react with carbon to make carbon dioxide, and it is a colorless carbon dioxide gas. And in case of phosphorus, phosphorus burns with the oxygen and produces dense white fumes of phosphorus peroxide. Reaction is here, and at the temperature about 3000 degrees centigrade, nitrogen react with oxygen to form the nitric oxide. Then oxidation of metals. So then after the oxidation of metals, it gives the metallic oxide like magnesium oxide, potassium oxide, sodium oxide and calcium oxide. So magnesium burns in the air with a bright white flame and giving white ash, and potassium, hard potassium, catches fire very easily and burns with lilac color flame, thereby forming potassium oxide. And in case of sodium, sodium burns with a bright yellow flame forming sodium oxide, and upon burning calcium oxide, it gives out a brick red flame. Now oxidation reaction are of two types, slow oxidation and rapid oxidation. So in rapid oxidation, it is very fast. Here for examples, burning of or combustion of fuels like wood, LPG, kerosene, petrol, etc. So carbon dioxide and water vapor are also released in combustion reaction along with heat. And in slow oxidation process, a substance slowly reacts with the oxygen and very slowly it forms the oxide. So here now that is rusting is a good example of slow oxidation. Here you know that if you place an iron nail in moist air, it slowly changes into brittle brown substance, and this brittle brown substance is called iron rust. The iron rust formed is different in its composition and its properties are different from those of the original iron nail. The chemical here, chemically the rust is not iron but hydrated iron oxide. Here iron react with oxygen in presence of moisture gives the iron oxide, that is rust. And rusting weakens the iron structure, and we have already learnt about the rusting and methods of prevention of rusting in the previous chapters. And oxidation of food. So you know that oxidation of food is called the respiration. We will discuss in our next video about the respiration. Till then, thank you.